In this video, we're going to be doing an impulse and change in momentum, Unit 3, work energy and power MCQ. So a 0.5 kilogram ball moving at 12 meters per second strikes a wall and rebounds at -8 meters per second in a time interval of 0.020 seconds. What is the average force that is exerted on the ball? So the ball initially is moving with 12 meters per second to the right, and then we are rebounded -8 meters per second after contacting the wall. So you would just plug these in and your time interval is 0.020 and you would just get -500 newtons with a calculator. And we want our magnitude, so the magnitude of F average is just the number 500 newtons. A force acts on a 2.0 kilogram object such that a velocity changes from 3.0 meters seconds east to 4.0 meters per second north. So our 2.0 kilogram object is here. Initially, we were going 3 meters per second east. Then we are going 4.0 meters per second north. What is the magnitude of the impulse that was delivered to make this change? So our impulse is equal to m delta v. So you can rewrite this as mvf, v initial, and we have our components. Our initial is that we are at 3, 0, and final, we can say we are at 0, 4. So if we plotted that, you would have your initial at here, and then finally you would have here. So we can say that our change in velocity is equal to -3, 4. Now, if we were to find the magnitude of this, this is equal to -3 squared plus 4 squared, which is equal to the root of 9 plus 16, which is 5. Now all you do is you take your magnitude and you multiply it by your mass. So impulse is equal to m delta v, which is going to be 2.0 times 5 equal to 10 newtons times seconds. A 1.0 kilogram object experiences a force that varies with time as shown below. As shown, it increases linearly from 0 to 10 newtons over 2 seconds. What is the impulse that is delivered? So we can draw this out as a graph. So from we go add this. So from 1 to 2, we go up to 10. We want to find impulse. And impulse is equal to the area under FT graph. This is going to be our force is going to be our this is 2 seconds, so we have time here and we have force here, so our shape is going to be a triangle. That's going to be 10 newtons times seconds, which is B. A 3.0 kilogram car initially at rest is pushed by a constant force for 4 seconds, giving it a final speed of 8 meters per second. What is the magnitude of the force? You can use impulse momentum A 0.25 kilogram puck moving at 20 meters per second is brought to rest by a force over 0.5 seconds. What is the magnitude of the impulse? So, impulse is equal to m delta v. Our mass is 0.25. Our initial is 0, and we subtracted 20, or our final is 0, and we subtract it by our initial, which is 20, and that's going to be negative 5 newtons. But if we want our magnitude, that's 5 newtons times second. A force time graph consists of a rectangle of height of 6 newtons, lasting 3 seconds, followed by a triangle that decreases from 6 newtons to 0 over 2 seconds. What's the total impulse? So we want to find what the impulse is. Impulse is equal to area under the FT graph. So you take the area of your rectangle plus the area of your triangle. You can split this up into it's a composite shape composed of different shapes. So we have force times time plus 1/2 of force times time. Those are actually in units of 18 newtons times seconds plus 16 newton times seconds. So your answer is going to be 24 newtons actually, because this is 6 to 3, this is 2 to 1/2 to time interval of t. So actually the answer for this should be 24. A 2 kilogram object moving at 5 meters per second experiences a constant force opposite to its motion for 1 second, reducing its speed to 1 meters per second. What's the magnitude of the force? Then we get our force for a time of 1.0 seconds. So then after that force, our object is now moving in the same direction, 1.0 meters per second. Force is equal to mass delta V So your answer is going to be C. Two objects collide. Object A mass 2 kilograms flows from 6 meters per second to 2 meters per second. What's the impulse on object B? So we can find the impulse on each object. Object A is m delta v. So m vf minus v initial, which is going to be a mass of 2 times final of 2 minus initial of 6, which is equal to negative 8 newtons times seconds. Now, we have to use Newton's third law, which states that the impulse on B is equal and opposite. So the impulse is equal to a positive 8 newtons times second, because the impulse is going to be equal and opposite. So you change the sign of your vector to positive, which is B. A 1 kilogram object moving at 10 meters per second experiences a variable force such that its momentum changes linearly to 0 over 5 seconds. What is the average force during this time interval? The answer is going to be -2 because the magnitude just looks at the sign. A ball is dropped and bounces off the ground. Just before impact, its velocity is -10 meters per second, and just after it is positive 8 meters per second. Which statement is correct about the impulse? So if it's positive, that means that it's going to be upward. So that means if it's a large change in velocity, is going to mean that you have a large impulse up. FG is still going to be down wherever you are on Earth, and your ground provides extra upward force to reverse your direction because you have that normal force. You have Fn. So your impulse is up, and it's also going to be greater than the weight during the contact.